Hello and welcome back, students. Welcome back from break. I hope everybody had a great winter break. I've been watching your Flipgrid videos, so I know that a lot of people had had a really great time. Go ahead and check out your Flipgrid videos, and you can talk to your friends and do whatever. Talk to them and let them know what you did over winter break, and tell them how cool their break was, and it's really fun time. So today we're going to be talking about animals in water, where we're going to be talking a little bit about their mass. All right. So before we get into what that means, your materials, please go find your whiteboard and your markers. So we might need to take a pause here, but you need to get your whiteboard and your markers, and then you need to get, if you can't find your whiteboard, this is the whiteboard I'm talking about, your whiteboard and an expo marker or some type of dry erase marker so that you don't ruin the whiteboard. And then if you can't find that, you don't know where it is, you got to have a pencil and paper or pen and paper, okay? So you can pause here if your students need a second to go find those things. After you've got your materials, you can start with today's mental math, or math fluency. So you can write these numbers down, or you can just show the greater than, less than sign, rate greater than, less than. Choose your level, do your 3 problems. Once you're finished, let your teacher know by giving them a thumbs up, or show them your answers, or send them your answers in the chat. Whatever your teacher wants you to do, just let them know once you finish. All right, so teachers, you can pause here and give your students some time to finish their mental math. So you were just making sure you're just comparing your 2 numbers and showing which one's greater than or less than. Once you've finished that, chosen your level, you can check out the answers in 3, 2, 1. There you go. So go ahead and pause here again, and you can give yourself a check or a smiley face if you got it right, and just give yourself an X and then show that you show the right answer if you got it wrong. Okay, so we've got all our answers, and now we want to look at today's lesson. So to start off today's lesson, I just want to talk about some prefixes. And prefixes are just the things that you put on the beginning of a word. You put it on the front of the root word. So let's talk about a couple of prefixes where you put at the beginning of the root word. There's this prefix called kilo. This is in the metric system. So in this metric system, we've got prefixes, and this one's called kilo, and it means 1,000. It means you have 1,000 of something. And then we'll go from largest to smallest. So we've got 1,000, then we'll go down to 100. The prefix for 100 is hecto, and then we'll go down smaller again, 10. So 1,000, 100, 10. Then we go to deca. So we've got deca right here. Those two, not that important. We don't talk about them that much. And then you have the root word. So there's no prefix. So the root words for a couple things in the metric system, you got the meter. So you just have a regular meter, no prefix. Then you got a gram. There's a gram, no prefix. And you got a second, no prefix. If you were to put one of these prefixes on there, you were to say a kilometer or a kilogram or a kilosecond, then that would just be saying you've got 1,000 meters or 1,000 grams or 1,000 seconds. That's what a kilogram or a kilometer or a kilosecond is. So this is the root word. It just means you have one of it because there's no prefix on it. We'll keep going smaller. So we go 1,000, 100, 10, and then we've got 1. And then we've got deci. So deci means tenth. That means you have 1/10 of something. Like a dime is 1/10 of a dollar. This means you have 1/10 of a meter or a gram or a second. So if I say I have a decimeter or a decigram or a decisecond, I have 1/10. So it's pretty small. 1/10, less than one whole, 1/10 of a meter, gram, or a second. And then we'll go down again to centi, which is 100th, even smaller than a tenth. And then a milli, which is 1,000th. So we went from largest to smallest. And I'm sure you've heard centimeter before. Centimeter, that means you've got 100th of a meter. Centigram, maybe. You've probably heard milligram. Milligram means you've got 1,000th of a gram. So I would say the most important ones to remember are kilo, which means 1,000, centi, which means 100th, and then milli, which means 1,000th. So if it's in blue, I would definitely try and remember it. Kilo, centi, meter, gram, and second. Okay, so now I want to talk about mass. I want to talk about what mass is. Mass is the amount of substance or matter something has. So anything you look at, it has mass or substance. This glass, it's empty right now. There's nothing in it. It's Coca-Cola glass. There's nothing in it. It still has mass, right? The glass is a substance, and there's air in here, very loosely packed air molecules. So there's some very light bit of substance and matter in here, but you can't feel it. You can't really see it. There's just not very much mass in here. But if we fill it with water, it has a lot more mass in here because the water molecules are much more tightly packed than the air molecules. So there's a lot of water in here. So the mass of this glass has increased significantly than when there was just air. Now we could increase the mass even more if I filled water up all the way to the top here, but I'm just going to leave it there for now so I can drink it a little easier. Now we're going to talk about some different ways that we measure mass with the metric system. Because some of you might measure your weight, which is a form of measuring mass, with pounds. I bet almost all of you know how many pounds you weigh. Weighing something is sort of like checking the mass, except for when you weigh yourself, you're just checking what your mass is sort of on Earth. Because weight is weight is just the force of gravity on mass whenever you're on a specific planet. So if I were to go to a planet with less gravity, like if I were to go to Mars and weigh myself there, my weight would be less. So I'm not going to tell you, I weigh an amount on Earth. Let's say I weighed 200 pounds, then I would weigh maybe 150 pounds on Mars. But if I were to go to Jupiter, the gravity's stronger. So my weight would increase and maybe I'd weigh 250 pounds instead of 200 pounds. The difference between mass and weight is that mass never changes. Weight can change though. So we're going to talk about how we can measure mass with the metric system of kilograms and grams. So we're trying to figure out what is the mass of a couple different objects. And I just want you to understand a couple basic objects. So on the left here, we have what is the mass of a grain of sand, so one tiny little grain of sand, or what is the mass of a drop of water? And the answer would be about 1 milligram, which if you'll remember is what? What is the prefix for milligram? It's 1,000. It's 1,000. So a milligram is 1,000th of a gram, very small, a thousandth of a gram, and that would be a grain of sand or a drop of water. Now you can think of what is the mass of a dollar bill, or even what is the mass of, I think I've got one here. Oh yeah, I got a whole box of them. What is the mass of this paper clip? Not very heavy. I don't have a dollar bill, but I have maybe I have a dollar bill. Let me see. 1 second. Let me see if I got a dollar bill here. Let's see. Yes, here we go. Okay. So they're both pretty light. The dollar bill feels a little heavier, but I think it's because of air resistance. So we got a dollar bill and we got a paper clip, and those both weigh about a gram. I don't have a grain of sand and I don't have a drop of water. And then the next thing, so 1 gram, the next thing you can think about is a cantaloupe or a laptop. So a cantaloupe weighs about 1 kilogram, which again, remember how many grams is that? How many grams? Well, it's sort of the opposite of a milligram. So instead of 1,000th of a gram, it'd be 1,000 grams. See the difference there? 1,000th is a milligram versus a kilogram, which is 1,000 grams. So you'd need about $1,000 to weigh a cantaloupe or to have the same amount of mass as a cantaloupe or a laptop, because those two things both weigh about a kilogram. So since we're really just talking about how we measure different things, how we can measure different things, let's just talk about measuring. Let's talk about measuring for a second. This is just some questions for some class discussion. If we want to talk about, what do you measure with Fahrenheit? What do you measure with feet? What do you measure with gallons? What are some other units of measurement? So not Fahrenheit, not feet, not gallons. Are they customary? Are they metric? And the last question, very interesting, can everything be measured? So right now we're talking about how do we measure mass, which is the amount of matter or substance something has. And now I just want you to talk about just measurement, these three questions, not just mass, but you can talk about how else do we measure mass, if not just with grams and kilograms and milligrams? Is there other ways to measure mass? So I'll stop talking and give you as much time as you need, teachers, to talk about these three questions. Okay, well, now we're finished having these fun discussions. Let's just make sure we really understand what we're talking about specifically today. Now that we've talked about measurement in general, mass, you matter to me. So mass is the measure of the amount of matter in an object. And so some of you might be saying, what's and matter is really just anything that takes up space. So if it takes up space, it's matter. I mean, air takes up space, people take up space, water, anything that takes up space is a form of matter. Your porch takes up, maybe you have a porch, maybe you don't, maybe your apartment takes up matter. All those things take up matter. The metric system is what we're talking about today. It uses grams and kilograms to measure mass. And so my next question for you, what does the customary system in the United States, what do we use? I already said it earlier. What is the system, what in the customary system, what do we use to measure mass? And you might say, what do we use to measure weight? And get you'd get the same answer for now. So what does the customary system use to measure weight? Once you've answered that question, so you can pause here if you didn't answer that question yet. Now that you've answered that question, 1 kilogram is equal to how many grams? So we already said this, but I want to make sure we really know. So pause here and someone say, how many kilograms is equal to how many grams? 1 kilogram, sorry, is equal to how many grams? So 1 kilogram equals 1,000 grams. Now, another interesting question would be, and I didn't write this, but now that I've thought about it, I have to share. 1 gram is equal to how many kilograms? So 1 gram, so switch those two words, instead of 1 kilogram, now 1 gram is equal to how many kilograms? Well, it'd be equal to, if we've already talked about it, 1,000th of a kilogram. So 1 gram would equal 1,000th of a kilogram, 0.001. Here, I'll write this all out. So we say 1 gram equals 1,000th of a kilogram. And how do we get there? Well, 1 divided by 1,000. 1 divided by 1,000 equals 1 divided by 1,000 equals 1,000th. And if you're not comfortable with division just yet, that's okay. What you can do is you can just remember that if you're trying to convert from grams to kilograms, well, you need to move your decimal place. There's an imaginary decimal right here, always, right where I'm drawing that pink big dot. Whoops. And you move it 1, 2, 3 places to the left. You draw your new dot. You need to add in, for your place value, add in your 2 zeros now. And now it would equal each other, and this is no longer a gram. This would become a kilogram. So if you're not comfortable with your division yet, you can just move the decimal places 3 to the right. And you can remember it's 3 because there's 3 zeros in 1,000. Okay, so just like before, now we have 1 kilogram equals 1,000 grams. And we can think, how did we get there? Well, we have 1, and then you can multiply. So last time we divided, this time we would multiply. You could multiply 1 times 1,000. So we need to convert from kilograms to grams. So that's what we're doing. We're converting from kilograms to grams. Maybe we want to figure out how many cantaloupes equal a paper clip, and 1 times 1,000 would just be 1,000. And again, just like last time, we moved our decimal place 3 to the left. Well, now what you could do, because again, there's 3 zeros in 1,000, now you can move your decimal place 3 to the right. 1, 2, 3. And then you just need to add your zeros. All right, so now let's practice it. Let's practice it. We want to convert, we're trying to learn how to figure out to go from kilograms to grams. And we know kilo, 1,000, it's 1,000 grams, or I mean, sorry, 1,000 grams equals a kilogram, right? So we have this handy dandy little bar at the bottom, and let's talk about how to use it in just a second. First, we need to figure out what's the problem. Well, the problem is that Raccoon bought a box of salt containing 30 kilograms of salt. It's a lot of salt. How many grams is that? So how many grams is 30 kilograms? Well, we can use this thing for now. You won't always have this, but for now, we can use this kilogram to gram conversion chart on the bottom. So we would find our kilograms, because we know we have kilograms, and then we need to find 30 on that kilogram. So we'll go all the way up to 30, 0, 5, 10, 15, 20, 25, 30 kilograms, and then we go down, we go straight down to convert to our grams. And sorry about this little toolbar at the bottom, it keeps popping up. So you can see there at the bottom left, there's a little G for our gram, and that's to show you that everything on the bottom is grams and everything on the top is kilograms. So we have 30 kilograms of salt. How many grams is that? 30,000. So like I said before, you won't always have this. For now, we can see it's 30 kilograms of salt. That is 30,000 grams of salt. But we can do it the way that we just talked about. So we need to go from kilograms to grams. So we would multiply by 1,000. So 30 times 1,000. 30 times 1, 2, 3, 1,000, 3 zeros, equals, and let me turn my face off, equals 30,000. Equals 30,000. And again, the one other way we talked about doing that is moving. So all numbers right after the one place, they've got a decimal right after the ones. So you got a decimal right there, and there are three zeros in 1,000. So you move it 1, 2, 3 spaces to the right, and then you fill in above your little lumps your zeros, and we get the same answer, 30,000. So there's 3 different ways you could have solved this problem. We just needed to figure out how many grams is in a box of salt. Okay, so we got one more problem, and then you got some stuff to do with your teacher. So Deer's rocks. So Deer likes to collect rocks, and Deer collected 2.5 or 2.5 or 2 5/10 kilograms of rocks. How many grams is that? So that's asking the same questions as before. How many grams is that for Raccoon salt? For Deer's rocks, how many grams is that? So we can solve it the same way. Let's do it the same order. First, we'll check out this little graph we've got here at the bottom. So we've got, and sorry about this toolbar again, we've got kilograms, and we need to find 2.5 on here. Well, here it is. Here's 2.5 kilograms. And we need to look at the bottom. So if we look at the bottom, we see that would be 2,500 grams. So our answer would be 2,500 grams. But again, you won't always have one of these nice little conversion charts. So you won't always know so quick how many grams is that? 2,500. So let's look at 2 other ways that you can do that. You can do 2.5. Whoops, that's a really bad 2. So you could do 2.5 or 2 5/10 or 2.5 times 1,000 equals 2,500. 2,500. Or again, if you don't love doing multiplication with multiple like 4 digits or with decimals, then again, you could do 2.5. How many zeros does 1,000 have in it? Well, it has 3 zeros. So you could move this decimal 1, 2, 3 places to the right. Fill in your bumpy lumps with some zeros, smooth them out. Ooh, nice and smooth zeros. And you'd get the same answer, 2,500. So the last thing that we're going to do with me here is you're going to pause for class discussion to answer these 4 questions. How do you convert from kilograms to decimals? That's the first question. What happens when we convert a larger measure of mass, such as kilograms? So kilograms are a larger measure of mass, right? They're bigger, there's 1,000 grams, to a smaller unit. What happens to your number? Does it get bigger? Does it get smaller? Are there more zeros, less zeros? How would we convert from grams to kilograms? And then what happens when we go from a small measure of mass, like grams, to a large measure of mass, like kilograms? What happens to our number? Does it get bigger, smaller? So answer these 4 questions. Pause, answer these 4 questions. I'll give the answers, and then there's 2 questions that you're going to do either on your own or with your teacher, based on what your teacher thinks is best. So pause here and answer these 4 questions as a class. So there's actually 3 right answers for this first question. How do you convert from kilograms to grams? Well, you could use that little bar chart we used before, this little bar chart kind of thing here on the bottom, this little table. You could multiply by 1,000, or you can move your decimal 3 spots to the right. What happens when we convert? So those are your 3. There's 3 short of options. What happens when we convert a larger measure of mass, such as kilograms, to a smaller unit, such as grams? The number gets bigger, which is kind of weird because you're going from a larger measure, kilograms, to a smaller measure, grams, and the number gets bigger when you go from that larger measure to a smaller measure. How would we convert from grams to kilograms? You divide by 1,000, or use your little chart. You could use that little thing here at the bottom again. If you have that, you don't always have it. You divide by 1,000, you do that, or you can move your decimal 3 spots to the left. So there's 3 options again. And last question, what happens when we go from a small measure of mass, grams, to a larger measure of mass, kilograms? Well, you're going from something small, a gram, to something large, a kilogram. So the number gets smaller. Also a little weird, but that's how it goes. Now you've got 2 questions to answer with your teacher or independently, whatever your teacher decides. And I hope you have a great rest of your day. Bye.